Oh, shoot. Did anyone bring their book today to exchange? Nice. Try to do that by tomorrow. We can certainly do that during the pre-test. And it's fine. But let's get that done by tomorrow and not take forever on that. Like I say, you should want a copy of that book at home, at least in case there's an internet disaster at home. It's a really great book. It's my favorite book, I think, as far as I can remember, I've ever taught out of. It's very user friendly. So, and there it is. Here's the beginning, chapter 1. And basically, we're just going to get into it. And I'll call this I'll section this off into certain concepts. This is basic concept number 1 if you want to organize your notes in really shorthand. Of course, as usual, I have cut things out of the book, with their directions just to prove the point that you don't even need me. What the heck is this? Yeah, I don't want to see that. Grapes? Is that grapes? Nice. Oh, is that the Spanish of grapes? Okay, concept number 1. Hey, brand new, unless you are in Math 3 honors. Okay, the crux, one of the main ideas of this whole book of trigonometry is coordinatizing an angle, putting an angle in a coordinate plane. Okay, so here you see not a coordinate plane, but I'm going to go ahead and add these to the drawings. Go ahead in these drawings, put your x and y axis. Now, I thought about this over the years and actually have expressed this to you last semester as well. Why do we obsess with putting things in coordinate planes? Well, so that we can mirror the world. We can put, we could treat like the starting position in the world as 0, 0, then any other position can be related in a coordinate plane scenario. That's if we're two-dimensional. Of course, there's three-dimensional math, and we could do the same thing, so on and so on and so forth. So we have to get over why are we putting an angle measure in a coordinate plane? The reason is exactly what I just said. So this is your world pretty much the rest of the year, except for a couple geometry throwback sections. Coordinate plane angle measures. All right? So look at this first angle measure. What do you think that measure, what would be a reasonable angle measure for this first one on the left that I'm pointing to, highlighted in yellow? Would 90 degrees be a reasonable? No. 180? No. What would it have to be between? Not 90 and 180, because I'm going like this. Oh, that's the wrong. That's the sound for. What is that the sound for? No, that's inverses, isn't it? Never mind. See, this is the first hour. I'm always so bad. If this is fourth hour, I'd be real quick on what that was. But anyway, what would be a reasonable between what and what? Come on, 270 and 360. So maybe let's just make up one. 290 degrees. Notice what we're putting on this. It's positive. So hence, from here on out, whenever you move within a coordinate plane angularly in a counterclockwise direction, that angle shall be labeled as a positive angle measure. And you either memorize it or you what? Don't. And then that's it. There's no get it's and I don't get it's or nothing like that. You do it. So then what does that mean about the opposite of that? If I go more direct and I go in this direction, from here on out, that measure shall be called a negative angle measure. Now, let's say these are the same two openings. What do you think that angle measure specifically has to be if this is 290 positive? Well, what's left over? 70, but it's not 70, it's what? Negative 70. And that's it. I'm moving on. Okay, they have this stuff over here. This is basic geometry. I don't think you have to write that down. Here's a segment that ends at 2 points. A ray is like a ray gun. Pew! Star Wars. And then a line goes off in two directions. Are you okay? All right. Concept number 1, over. Okay, do we really have to write this down? Hold on, we have an interruption. Oh no, wait, hold on, don't move. Don't you already know this? This is such a what angle? Oh, how cute. Right? Obtuse. Straight. And now, probably for your first time in forever, you have angle measures that are greater than 180. You're going to have angle measures that are greater than 360. Heck, you're going to have angle measures that are greater than 360 today, greater than 720. Could go off into infinity. All right, and we're going to describe that. Do you think you have to write that down, yes or no? You do? Okay. Okay. You might want to write this down because students often flip coins on this. And then that stuff in blue over here is for the next thing. You don't have to write it down, but I found it a point of interest. All right, for this scenario. But complementary and supplementary. Okay, and I think it could be tied into, this little section as well. All right, what comes first in the alphabet, C or S? What comes first, 90 or 180? How could you screw this up? Complementary angles add up to what? What measure? 90. C, 90. Supplementary add up to what? 180. Should be no problems with that. I think there's questions like this on this concept tomorrow, maybe a little bit today. All right? So go ahead and sketch that down. I'll press pause. We're going to call this concept number 3. And you may see this throughout the year when we break down angles into degrees, minutes, and seconds. You're really going to be tested on this, in this chapter for sure. Hey, by the way, this should be easy. And I don't know why this was the norm, but how many minutes are there in an hour? So how many minutes can I break down 1 degree? It's the same answer. What's the answer? 60. And then how many seconds are in a minute? 60. So how many seconds are in a minute when we're talking about angle measures? 60 again. Hey, let's one more question. How many seconds are in an hour? 3,600. So how many seconds can I break down a degree into? 3,600. It's the same scale, if you want to call it that. Now, why would you want to do that? I think I looked this up once, that 1 degree, well, here we go. No, it's actually looked up right now. I'm a moron. I did this on purpose. And why would you want to break down a degree into 3,600 seconds? And I think with one class I actually did this. It's because, how many people have heard of a nautical mile? And I never knew this until I looked this up. Nautical mile? It's a mile on the sea, which is different than a mile on land. And the reason is, you might want to write this down, not all of this, but 1 nautical mile is actually, where's it at? I want to get it right. 1 minute of latitude equals 1 nautical mile. 1 minute of latitude, not 1 degree. So if I find a location of something on Earth and I just use degrees, there is a massive amount of space with 1 degree compared to nautical miles. 1 minute, 1/60th of a degree of latitude is, where's it at? I thought they had the number right here. Not 5,280. 5,280 feet times 1.15. It's a little bit bigger. So that's why we want to break it down to seconds, because you can even locate even further and closer where something is on our globe. All right. So just selling the point of what what a nautical mile is. 1/60th of a degree of latitude. So it is important for locations of things on Earth, so on and so on and so forth. All right. So they have a couple of conditions here, and I put that down here at the bottom. 3,600 seconds equals an hour. So 3,600 seconds equal a degree. So a degree is comparable to an hour, and it's broken up into 60ths and then broken up into 60ths again. And again, why would you want to do this? It's for pinpointing things on Earth as an example of that. So I'm going to show you a couple things on this, and then you have to be able to deal with that. And you don't have to write all that down. Just make sure you understand 1 minute equals 1/60th of a degree. Okay? Or another way you could write this is 60 minutes equals 1 degree. Right? Because that's the truth. And then 60 seconds equal 1 minute. And 3,600 seconds equals 1 degree, just like I was saying with the hour. A degree is like an hour as far as how it's broken down. And everyone understands hours, so everyone should be able to handle degrees. All right, so this is going to take a minute. This is the one where students, I don't know why we struggle with this, but it's really not too bad. Okay, and the first thing they ask you to do is this, and I'm just going to show you the answer because I think we should understand that. What if I had to take 74 degrees, 8 minutes, and 14 seconds and convert it to a decimal? Well, you do exactly what we said, what 8 minutes means. And what it means is it's 8/60ths of a degree. All right? 14 minutes is, 14 seconds is 14/3600ths of a degree. And basically, you just add those decimals on at the end and end up getting this decimal degree here. So I give you a chance to write that down. This really should not be a big deal here. My voice is getting worse. I hope no one can hear this on the. Okay, I'm locked in. Here we go. Get nice. Okay, where did it put me? Where am I? Okay, here we go. Okay, now you're not going to write all 7 of these. You got your Chromebook open over there, right? It's the Powerball. Okay. So you take this 0.87 and you multiply it by 60. Everyone should understand that. All right, and then that gives me 49.02. Isn't 49 minutes less than an hour? Yes, yes, yes. Okay, so that means that's less than a degree. What do I do with the 0.02 now? You multiply that by 60 again, and then that turns that into seconds. And then you don't go any further than that. You leave the decimal in the seconds. So this is reversing the scenario, and that should make perfect sense. Is it a node? Nice! I'll see you guys. Oh, what am I doing? I got all excited because George said I won. For a second. I'm going to see. Let me press freeze for a second. I thought I had some incomplete notes. Okay, the grade school ones, I kind of just I have the answers because you don't need me for this, and actually this is going to happen for you tomorrow anyway. So here we go. Boom. Some things that we should know that I assume you do know, but I will present them as for maybe. Did I press pause? No. I press play because I want everyone to know what I'm going to. This is like 2 minutes. We're stuck on this, and I can't move the screen for like the 4th time today. Okay, we'll do it again. At some point, let's try this. Let's try sliding this around. Hey. It's the best notes ever. I've never been locked this long. One more time. Oh, I remember how to get out of it. I'm out of practice. Nice. Good. There's all my notes that I was doing before that just showed up randomly. All right, good, good, good. Nobody cares. I all lost interest. All right, grade school. Grade school. Grade school time. Time for grade school. If I had to subtract these two, all right, and I'm sorry it's already 9 o'clock because it's with their little computer mishaps. I can't stop the video anymore. It's just incompatible. Something's going on here. So if I took 90 degrees, and you should be able to do this without a calculator, and it won't work out very well if you find some specific. I'm not even going to show you where those buttons are. We're done. If you tried to do this, do you have anything to subtract from 20? Sorry, that's a mishap. From minutes over here, do you? What can I take minus 28 minutes? Nothing. So what you got to do with 90 is turn it borrow. And Lexi Samuels would understand this because last year she did subtraction by borrowing when she runs out of, like enough numbers to subtract from the previous one. So that's just a weird way of saying that. I'm going to make this, isn't 89 minutes and 60 seconds the same thing as 90 minutes? Yes! This is not rocket science. I shouldn't blow somebody's brain gasket right now by me making that happen right there. I need to borrow a degree and throw it into the minutes part. And now I can. And yes, you do like subtract and subtract. All right, so we subtract down from here, and then we'll be able to get this answer. What's 60 minus 28? 32 minutes. What's 89 minus 51? I don't know. Can someone my brain's fried right now after. Is it 38? All right, 38 degrees, 32 minutes, right? Ain't no thing. Anyone? Chicken wings. And then bologna sausage. I'm going to go ahead and add these two. And then I'm going to subtract the 8 minutes and 15 minutes at the end. And then see if I have to do some reconfiguring of my answer. So just add the degrees, because it's just adding. 55, 65. Is that 67? Is that right? 55 plus 12? Yes, Mr. Samuels. All right, and then what's 30 plus 44 first hour? A number? 74. Nobody says a dang word in this class. Do you notice? Do you see this? I have a witness now. All right? All right, and then minus. Now we're going to minus just like we did that last one. And yes, you do minus the 15 minutes from the 74 as well. Okay? All right, 74, 64, 59. We're lucky. Hey, what do you think if this was more than 60 minutes? What do you think we'd have to do at the end? Add a degree, throw a degree over there, and then reduce the minutes by 60. And then is that 59, 59? Nice, isn't that weird? That was easy. Shorter than if I had to go to and if you went to the calculator, this is what you'd have to do. You'd have to convert these to decimal degrees, add and subtract, and then reconvert them back to degrees and minutes. This is faster. Grade school. All right, let's move on because of the time and the computer mishaps. You know what all this crap says? All this crap says is what I just said already. We're going to throw angle measures in a coordinate plane. What do you think a reasonable measure is that right there? What do you think that measure is? 80. Well, that seems a little big. I'd say like 45, 50, right? Sorry, I didn't mean to say you were wrong. Reasonable answer. But here's the thing. Listen, all this rigmarole up here, all that they say right here, the initial side when you put an angle in a coordinate plane shall always be the positive x-axis. This is where every angle is going to start for the rest of the year when we throw angles in a coordinate plane. What's terminal mean? End. The terminal side can end anywhere. All right? Now, I will play a little game already to get you to understand what's happening in this little thing. What do we say? Let's say this is 50 degrees. By the way, is that positive 50 or negative 50? That's positive 50. I got a question because we're running short on time, but this is really the main last idea. What do you think that measure would be then? Negative 310. Where are they getting 310 from? What do these two add up to be, the green and the red? 360, a full circle. There he goes again. Don't take so much this time. I'm going to run out of toilet paper. All right, what do you think this angle measure is? Approximately. Okay, well, first of all, initial side and then terminal. What do you think a reasonable angle would that be? 160. So let's put that in red. If this is 160, that's positive because we're going counterclockwise. What would this measure be? What would that measure be? Negative 2. Is it 20? No. Negative 200. I was never good at math. That was an easy one, actually. Yeah. What now? I can't hear what you're saying. All right, and then don't forget this. This makes me sad. This makes me infinitely sad. Where are the coordinates numbered? And they start in the upper right corner, and then they actually get numbered counterclockwise. So do understand your 4 quadrants, what they are, because you will be asked that consistently this year. What quadrant does this angle land in? And if you don't know your quadrants, you're doomed. I don't want to press pause because it'll lock up my notes again. Then I'll be sitting here like a buffoon trying to get the thing going. We've already wasted about 6 minutes on that. Isn't that true? Are you sure I didn't win? Did I actually win? Then you're going to mug me later and take the ticket? Get your little basketball team together? Don't worry about these. We'll work through this as we go, as we move on. Okay, but that is actually true. From 270 to 360, positive degree measure. In between that, you'd be in quadrant 4, which you've already seen. So take those notes down. All right, there's one of the things where the notes went off. Nice. And I already, that's all that garbage when I was locked up. So I love this question. If you want to go ahead and write the idea of what, can everyone say co-terminal? One person. That's great. Co means what? Co. And when I say my coworkers drive me nuts here, what does that mean? They are the what people? The people that I work with at the same place. All right? Not all of them. So here we go. And the math should make sense out of this. If you start off with saying, okay, directly, in a direct positive direction, this is 60 degrees. Well, we already played this game. Well, then, to go in a negative direction, and starting at, I'm going to make this real red to stick out, starting at the initial side, which is always the positive x-axis, but then going directly clockwise to the same position, that's negative 300. But wait, there's an infinite amount of possibilities as you write these notes down. Oh no. Okay? And the infinite amount of possibilities is, can't you be in Walmart's parking lot illegally doing a donut? And then what if I start at Walmart's parking lot and I'm facing at the W and I do one spin counterclockwise and I end up at the W? What do we call that? Hey man, I just did a what? No, I start at the W and end at the W. I just did a 360. I'm so cool. But now you can tell your friends, hey, I went clockwise. I actually did a negative 360. And then we're like, oh, he's so cool. And then, but then what if you started at the W and you spun twice counterclockwise? What is that called? 720. What if you go clockwise twice? Negative 720. Do you see how the infinite possibilities come about now? All right, and that's what this world, that's another expansion of your world. The main ideas today, all the rest was kind of review. Positive and negative angle measures, and we're going beyond 360, man. All right, and then I don't think you need two examples of this, but look at that. Hi, caramba. 110 degrees. That'd be equivalent to negative 250 degrees, or co-terminal, same terminal side. But now they get nuts. You want to get nuts? Let's get nuts. Let's spin once. Let's spin twice. And then go to 110. Who had more fun? 110 degrees or 830? Who has a more chance of throwing up? 830. I would throw up. I don't like circular moves. Okay? All right, hold on. Oh, you're going to make me press pause? We're just going to do the question online. Go ahead. Oh. 360 plus 360 plus 110, right? Just think about it. It's all based off of 360s when you go more than one rotation. But this movement is you're spinning. You're with a real illegal group. All right, ready, set, go. Hit the gas. Woo wee. 1, 2, blah, 3. But we all end up facing the same direction when we're done. But you just had more fun with the 830 degrees. Got it? You seem upset. All right. So now, here's how easy this should be. Find the angle of least positive measure, not equal to this, coterminal with the given angle. What do you think you do with 1,000 degrees so you get the least positive measure that ends up in the same spot? I don't have time. Subtract 360 until you're under 360. So subtract 360 once, subtract 360 twice at least. That's 720. What are you left with? Somebody give me that answer. Come on, hurry up. Then I could graph it and then, really graph it. 280? Okay, so here's 280. Meow. Here's 1,000 degrees. 360, 360, then a 280. Who had more fun, the green movement or the red? But the point is, that's a coterminal angle. We just get there directly, and that's the ability that you need to do. And then, really, the rest of these questions, you could look at my notes that may or may not be complete online to show what these are. This just says find two positive and two negative coterminal angles. What do you think I do to 90 to find another positive coterminal angle? Add 360, and then another one, add 360, and then to get a negative, subtract 360 and subtract 360. All right, and then that's what all of these are. I'm going to probably have to help you with this one. And then there's another one of our mistakes. I think this is really the same idea. And then the only one you won't know how to do is this one. So, at the end of the notes, I could probably, if we have time at the end of tomorrow, because I don't think anyone's taking a full period on the exam, we'll be fine. Okay, whoops. Oh, I didn't want to have that online.